All right, guys. So that was another little video, whatnot, that I just want to share with you guys because I thought it was kind of neat that these people are kind of crazy at. Oops, pardon me. Okay, these people are kind of crazy in the fact that, like, you can do these amazing things, all right, and it doesn't come easy. Like, you have to work for it. Like, it's not something that you can just, like, all of a sudden go, oh, I'm going to go ahead and dunk a basketball. No, you have to, like, take your time. You have to work your way up to it. That's with anything in life. So the same thing with math. I know when you first get to it, you think to yourself, there's no way I'm ever going to get this. And, if you stick with it, I know you guys can do it. Okay, you got to believe that yourself. So then a little crazy video to start off, but here we go. Our next section today we're going to take a look at is systems of linear inequalities. Okay, and we're basically doing what we did last Thursday and Friday, and we're putting it into a system now, okay, with less than, greater than signs, so on. So a system of linear inequalities involves two or more linear inequalities, okay, two or more. The solution set to a system of linear inequalities is represented by a shaded graph. Okay, so to graph a system of linear inequalities, you must first be able to graph a single linear inequality. Here's some practice on a single linear inequality. Negative x plus 3y is less than or equal to 6. Get y by itself. So I'm going to add x over. 3y is less than or equal to x plus 6. Divide everything by 3. We get y is less than or equal to 1/3 x plus 2. Now again, mx plus b. Here's your b. It's your y-intercept. Go up 2 and plot a point. 1/3. From this point, I'm going to go up 1 over 3. So up 1 over 3, 1, 2, 3. Okay. Hi. Okay, so once you have these 2 points plotted, here's the catcher, or the kicker rather, not catcher. It's less than or equal to. Because it's equal to, we're going to draw a solid line. Okay. And then less than means we're going to shade everything below it. Okay, less than is below, greater than is above. So we want to typically, when we shade, do lines in the direction of which way the original line is going. You'll see why in a few minutes when we get to the systems. But this right down here, okay, is our solution set, which means that all of these points work for this particular inequality. Think about it. 0, 0, 0. If I plug 0, 0 in over here, is 0 less than or equal to 2? Yes, it is. So it works. But if you pick a point up here, let's say like 0 is 5. Is 5 less than or equal to 2? No, it will not work, okay? So that's the difference there. Cool. Number 2, y is less than 2. Now, if you remember from back when we did all y equals being horizontal lines. Now, the difference here is y is less than 2. We're going to use a shaded or a dashed line to represent our inequality graph. Okay, like notice this one's solid, this one's dashed. Less than's everything below, so I'm going to go in the direction that it was in. Okay, cool. So everything down here works, everything up there does not work. Okay, the reason we do dash as opposed to solid is because any point on this line will not work. Meaning, the point 0, 2. If y is 2, is 2 less than 2? No, that's why we have a shaded line indicating that's not part of our solution set. Okay, cool. So if you combine more than 2 of these linear inequalities, you will get a system of linear inequalities. Remember, a dashed line means less than or greater than. A solid line means less than or equal to or greater than or equal to. Okay, so we're going to go ahead and try out a system down here. Now, we're going to work our way through this nice and slow. Let's start out with the first one, okay? X is greater than or equal to 0. The line x is equal to 0 is just a straight up and down line, okay? So I'm going to go ahead and highlight it here. It's kind of hard to see it, but now, greater than or equal to means everything to the right. Notice that I'm going to just shade straight up and down lines going to the right, okay? Pick one direction, stick with it. You'll see why. Not the band either. Even though, I've heard it's a good band. They have the best song ever from what I hear. Okay, so now, if I add x over, okay, because I'm trying to get y by itself here, 3y is less than or equal to x plus 6. Divide both sides by 3. Y is less than or equal to 1/3 x plus 2. All right, so plus 2 is right here. Okay, up 1 over 3. Less than or equal to solid. Okay, and less than means below it. So I'm going to pick the same direction. Okay, now if that was it, then the answer would be the part where it's double shaded, right here. But I have one more. X is, or y is greater than x. The line y equals x starts at 0, 0, goes up 1 over 1. Okay, so this is a dashed line. And it's greater than, so it's everything above. All right, so everything above would be this way. Okay, now I know it's tough to see it and it can get confusing quick, but the only part where all three shades are meeting is right here, smack dab in the middle. So your final job is to kind of shade that in. Okay, and there's your solution. If you would like, you can do some test points to verify that. Okay, like pick a point right inside of here, and you'll see it works. Like if I was picking a point, I'd pick 1, 2. So if we test 1, 2, is 1 greater than or equal to 0? Yes. By putting 1 and 2 in for x and y respectively, -1 plus 6 is 4. 4 is less than or equal to 6. Cool. And is 2 greater than 1? Yep. So we've all good. If you check anywhere else, it will not work. Okay? Wonderful. So let's go ahead and get to the back. Now, application problem. A monthly magazine is hiring reporters to cover school events and local events. In each magazine, the managing editor wants at least 4 reporters covering local news and at least 1 reporter covering school news. The budget allows for no more than 9 different reporter articles to be in one magazine. Graph the region that shows the positive combinations of local and school events covered in the magazine. So here we go. I'm going to call X, what do we see here? Local. Okay, X is local. Y is school news. Okay, number. Okay, so those are the two things I'm talking about. Reporters for local, reporters for school. Okay, so number of local reporters. Awesome. Now it says we want to have at least 4 local news. Okay, so X must be greater than or equal to 4. At least 4. At least 1 reporter covering school news. So Y must be greater than or equal to 1. Okay, but it says not more than 9 different reporters articles to be given in one magazine. So I know that X plus Y needs to be less than or equal to 9. But there's one more little thing here. What does it need to be greater than? What do you think? Like over here, it needs to be bigger than 0. Okay, so the one thing that we have to make note of also is X must be greater or equal to 0, Y must be greater or equal to 0, because you can't have negative reporters. I wouldn't be like, oh, I have -5 reporters, okay? So what that means is, really simply put, is we're going to have to be in quadrant 1. Okay, so I know I'm going to be in quadrant 1. So these two, like, I know they're important, but if you can just kind of recognize that we can't have negative of something like that, then you can just stick to quadrant 1 and be in good shape. X is greater than or equal to 4. So it's a vertical line at 4. Okay, it's everything to the right. And again, I have to stay in quadrant 1, so just to make it a little bit less messy, it's up there. Y is greater than or equal to 1. Here's my line going across at Y is greater than or equal to 1. It's everything above it. And the better you get these, the more you can like kind of condense down your shading region. And lastly, X plus Y is less than or equal to 9. Well, get Y by itself. Okay, negative X plus 9. So I'm going to go up to plus 9. My -1 for my slope, because mx plus b. Down 1 over 1. Down 1 over 1. Okay, it's a solid line. And it's everything less than it, so below it, well, that means I have to be stuck right here underneath that one, but above both the other ones. So any combination inside of here will make this work. Okay? Awesome. So, I'm going to stop right there. Okay? I'm going to let you guys try out the last one, give it a shot, and we will come back to it in just a few minutes and try to make another video for you guys. And again, as always, keep up the good work. Good luck. We're all counting on you.